Modeling, Topic 6, Section 2, Simulating Portfolio Values using GBM, also called the Random Walk Model. So simulated VAR and GBM to estimate the risk of a portfolio over multiple periods with contributions, which we're going to be doing later in this course. We're going to have to simulate periodic asset price movements. We won't be able to just use a VAR formula to calculate the risks. A widely used model for simulating asset prices is the Geometric Brownian Motion Model, GBM, also called the Random Walk Model. This model says that the portfolio value next period, V1, is the portfolio value today times 1 plus the expected return plus a random value here, a random z, times the standard deviation. So I expect a return of mu, but there's a random shock to the system that's a function of the standard deviation. In this case, that random z value here, which I have listed here as z of n01, that is the random z from the standard normal distribution. In Excel, we use the function normS inverse rand to generate this random variable. Just to give you an idea what that random number looks like, I'm going to go back to the spreadsheet and under Simulated Randoms worksheet in the workbook. Notice I have a formula here that's rand open close. Now every time I hit F9, I get a new random number and I've copied that formula down for 10,000 rows. So these are 10,000 random numbers from Excel. However, notice in Excel, the rand function gives you random numbers between 0 and 1 with an average of 1/2. Notice the average of all these random numbers is 1/2. For our random walk model using a normal distribution, we don't want random numbers between 0 and 1. We want random numbers that are normally distributed with a 0 mean and 1 standard deviation, so we can use that to scale our standard deviations for the VAR calculation. So now notice I have the formula normS inverse rand. Now every time I hit F9, I'm recalculating my spreadsheet, and notice I get half the time it's a positive number and half the time it looks like it's a negative number. And actually the average of those 1,000 or 10,000, or I guess it's 1,000 random numbers, the average is 0, and the standard deviation of these numbers is 1. If I did a histogram, what you'd notice is these numbers form a bell-shaped curve. These numbers, the 0, 1, form a rectangle or uniform distribution. So that's what it means to have normS inverse rand. It is a random number with a 0 mean and 1 standard deviation, and that's what my VAR formula requires. So let's go back to our lecture, and here's how I'm going to do it. I'm going to randomly generate portfolio values. Those portfolio values using our full formula is going to be today's value times 1 plus the daily mean for t days, and we'll just keep doing 252 days for now, plus the random number z, normS inverse rand, times the daily standard deviation times the square root of t. So let's go ahead and do that calculation. Let's go to our spreadsheet, go back to sheet 1, and what I'm going to do is I'm going to put in my random z formula equals normS inverse rand. Now notice every time I hit F9, I get a random number. Half the time it's negative, half the time it's positive. If I look at the distribution of these numbers, it's going to be a 0 mean and a 1 standard deviation. And then I'll do the simulated portfolio value. Now I'm going to cheat a little bit here. I'm going to grab this formula here, which is the VAR loss formula. I'm going to put it right here. All right, so now I have the same formula. However, I don't want this to be the loss. I want this to actually be the random portfolio value. So I'm going to start off at $V. I'm going to get 1 plus the mean plus a random z times the volatility. So now this number here, whoops, I need to do one more thing. That z value, I'm going to replace that with this new random z value, which I gave the range name of RZ, random Z. So now every time I hit F9, this cell in B16 is the random portfolio value. Let me take out the negative sign there. So there's my portfolio value. And again, this is a $100,000 portfolio. It's expected to go up by 5%. So if I took an average of, say, 5,000 of these simulated portfolio values, it would be $105,000. However, every time I hit F9, it's a different shock. This one, I've made an extra money, and I'm at 113. This is another positive shock. I mean, look, it's a random shock of a 0.8 positive standard deviations. But here's a really bad day or a year. Here's a negative shock, a random negative shock of negative 1.2 standard deviations, and my portfolio is now only worth $81,000. So this is how we simulate portfolio values using Excel. Now, to calculate the VAR, I need to take these simulated portfolio values and then calculate the portfolio gain or loss. So let's go back to our spreadsheet. And I'm going to fill in this cell here. I'm going to take my random portfolio value and subtract my $100,000. Now this number here, this is the random gain or loss from the original portfolio value of $100,000. Now the last thing I need to do to calculate a simulated VAR is I need to take, say, 5,000 of these values and paste them here. Hit F9, paste it here. So let me do a couple of them. Copy, Alt-H-V-V to paste it as a value. Notice every time I paste in Excel, I get a recalculation. So here's my next random gain or loss. I'm going to paste it there, Alt-H-V-V. And if I did this 5,000 times, I can then get 5,000 possible portfolio gains or losses. I would then calculate what is the 5% worst case loss, and that should be equal to my 95% confidence interval VAR. And that's what we're going to do in the next topic. In the next topic, we are going to use macros to automate the process of getting 5,000 simulated portfolio gains or losses.